Okay, we talked about what light is, now we're going to talk about what it does. So the first thing light does is when it strikes a surface, it can reflect right back at you. Now, not all the light will reflect. It's a little different than throwing a ball at the wall where the whole ball comes back. With light, some of the ball is going to bounce back, but some of the ball is going to go through. So it's a little weird. Some's transmitted, some's absorbed, but the more reflective, the more shiny something is, the more of the light gets reflected back at you. So all a mirror is it's a surface designed to reflect as much of the light as possible. Now, the nice thing about how light reflects is it's the same as the way anything reflects. The reason you can bounce a basketball to your friend is you know if you shoot it down at a certain angle, it's going to hit a flat surface and come right back at the same angle. So if you bounce it right between you, it'll come up to your friend. Light's the exact same way. The angle the light comes in at, or what we call the incident ray, is always at exactly the same angle as the light coming out. So the light coming in is going to have the same angle as the light bouncing away. Both angles, by the way, are measured from this weird line we call the normal. The reason we measure from the normal, or from basically an imaginary line perpendicular to the surface, is it makes the math a lot easier, especially if the surface isn't totally flat. We can always have a normal where it hit. Now, why does that create an image in a mirror? Why, when you look at a mirror, do you see yourself? Well, it's more based on how your eye works than any property of the mirror. Now, the reason you see something is you see a cone of light entering your eye. Now, what the mirror does is it tricks your eye into thinking the light came from somewhere it really didn't. So, for example, if you look at the picture here, the light really comes from the object, bounces off the mirror, and to your eye. But your eye doesn't know that there's a mirror there. It just knows it got this cone of light. So it sees the object as being behind the mirror. That's where it appears to come from. Now, the reason it's where it appears to come from, not where it actually does, is why we call it a virtual image. So a virtual image is one that no light actually comes from. It just seems that light comes from that point. Okay, rules for images in a plane mirror, really simple. There's a couple of terms that we're going to throw out at you that you're not going to know. That's the only difficult part. The actual image itself is pretty easy. The first is, if we have an object, we place the object at a distance DO, O for object, from the mirror. The image will form at a distance DI, distance image from the mirror. Now for a plane mirror, it's really easy. The object distance DO always equals the image distance DI. So if you know how far something is behind a mirror, in front of a mirror, the image is the same distance behind it. Now, the other thing we're going to talk about is HO. HO is not surprisingly the height of the object. HI is the height of the image. And for an image in a plane mirror, again, they're the same. So, here are the properties for rules in a plane mirror. It's always upright, it's always the same size, it's always the same distance from the mirror, and it's always virtual. By the way, a really common misconception is that mirrors flip the image. That's why, ambulance is written backwards on the front of an ambulance, so you see it the right way in your mirror. By the way, it's not the mirror flipping the image. I mean, if you look at the picture, everything in the mirror is exactly on the same side it is on the object, and it's the same distance. That's why the image appears backwards. The reason that it looks like it's flipped is when you're looking at that ambulance in the mirror, you're looking forwards at something that's behind you. So, in fact, you're flipped, not the image. Okay, plane mirrors are cool. Curved mirrors are even cooler. Now, a curved mirror can be thought of as basically taking a huge metal sphere and cutting it out. And depending on which side you take, that's the type of mirror you get. If you take the left side, you get what we call a convex mirror. If you take the right side here, you get a concave mirror. By the way, best way to remember that is concave. It looks like a cave. Now, the properties of that mirror are determined by what the center of that sphere, that circle that made them, would have been. We call that the center of curvature, C. And that's basically, if we made the mirror go all the way around in a circle, what would the center be? So, concave mirrors, we also call converging mirrors because any light that comes flying in will go out through the focal point. No matter where it hits the mirror, it's always going to come out through that point F. Now, the cool thing about that is that focal point, we know where it's going to be because it's exactly halfway from the center. So, in fact, if we were to double the focal length, that'd be the center. So if we take a mirror that's curved, say 20 centimeters, we know the focal length is going to be 10 centimeters. So the focal length is always 1/2 the distance to the center, okay? And remember, that's important because that's the point the light gets focused through after it hits your concave or converging mirror. Okay, the last type of mirror is called convex. You don't see them as much in optical devices, but you see them all over the place. Your rear view mirror in your car, in stores, anywhere you have those wide angle mirrors. Now, they don't actually converge light, they diverge the light, because if you think about it logically, light hitting it is going to bounce off. Angle of incidence equal angle of reflection, it's going to bounce away. Well, the neat is it's going to bounce away as if it came from a focal point behind the mirror, so we call it a virtual focal point. Again, that virtual focal point is half the virtual center, and it diverges the light. It basically spreads it out. So you can't use it to focus light, but it's really useful because since light travels the same direction both ways, if you got light coming in from there, it actually comes out straight. So you can see a much wider angle of view, but everything you see is going to be smaller and is going to be slightly distorted. By the way, that's the reason, if you ever wondered, the images may be closer than they appear in your rearview mirror. It's because it's convex. So cars seem a little smaller, and obviously if they're smaller, you think they're farther away than they actually are. All right, next lesson we're going to look at how do you actually find the images in these mirrors.